Beneath the vast celestial expanse, a massive scarlet star, one of the most luminous and easily distinguishable stellar bodies, asserts its dominance along the horizon. Situated far beyond our full understanding, this immense cosmic entity possesses the capability of releasing an energy magnitude that could rival the combined radiance of an innumerable array of stars. This astronomical giant, possibly on the verge of an apocalyptic event, may soon unleash a burst of such magnitude that it could outshine a billion suns. The real question is, are we prepared for the aftermath of such an event? This colossal red star, often referred to as Goliath, resides relatively close to Earth and has emerged as the focus of significant fascination and debate in both the scientific community and the broader public. Recently, this star underwent a considerable transformation, prompting growing concerns among researchers and fueling intense discussions about its future trajectory. The most alarming possibility is that this change may indicate the early stages of a supernova, an explosive stellar phenomenon marking the final phase in the life cycle of a star. If Alpha Orionis, the scientific name for this star, were to exhaust its nuclear fuel, it might collapse under its own gravitational pull, triggering a catastrophic explosion. The very thought of such an event sparks anxiety, not just among scientists but also among Earth's inhabitants, as the potential consequences could be extraordinary. Alpha Orionis, easily recognized by its striking crimson hue, holds the title of the largest and most radiant star in the Orion constellation. With the aid of advanced tools such as NASA's Hubble Space Telescope, astronomers have closely observed its behavior, particularly in 2019, when it experienced a dramatic loss of mass, a phenomenon considered rare for stars of this type. This raised alarms within the scientific community at large. While our Sun frequently undergoes coronal mass ejections, the unusual event witnessed in Alpha Orionis has sparked a re-evaluation of what occurs during the final stages of a massive star's life. Scientists are currently divided over the precise distance of Alpha Orionis from Earth. Estimates vary, with some placing it at 1,200 light-years away, while others suggest it might be as close as 724 light-years. The difficulty in accurately determining the position of stars like Alpha Orionis lies in the immense distances involved and the peculiar nature of red giants. Despite uncertainties regarding its precise location, Alpha Orionis continues to captivate observers as one of the most awe-inspiring objects in the night sky, shining several times brighter than our Sun. However, this radiant glow comes at a significant cost. Alpha Orionis is consuming its nuclear fuel at a rapid pace, accelerating its journey toward the inevitable end of its life cycle. Once it exhausts its fuel supply, the star will likely collapse, possibly forming either a neutron star or, in a more catastrophic scenario, a black hole, depending on the manner in which the explosion unfolds. This leads to a pressing question. Could Alpha Orionis represent a threat to Earth? If a supernova were to occur within a few light-years of our planet, the ramifications would be devastating. A supernova can release an unimaginable amount of energy, potentially outshining entire galaxies, which presents the possibility of far-reaching consequences, even if Alpha Orionis lies at a significant distance from our planet. Historically, the last supernova event recorded within our galaxy took place in the year 1604. Since then, humanity has not witnessed a similar occurrence on a local scale. However, a significant supernova erupted in 1987 in the Large Magellanic Cloud, located a staggering 169,000 light-years away. Although this explosion had significant effects on its immediate environment, it posed no direct threat to Earth. Nonetheless, these rare events serve as potent reminders of the immense scale of supernova explosions and the dangers they may present. A supernova, particularly one occurring close to Earth, could create what has been termed a danger zone around the stellar explosion. The risks to life on Earth, however, should be viewed in the broader context of cosmic events. While supernovae are infrequent occurrences, gamma-ray bursts, GRBs, represent an even more potent threat. These bursts are capable of annihilating entire planetary biospheres and flooding them with deadly radiation. For instance, GRBs have the capability of destroying a planet's ozone layer, leaving it exposed to harmful ultraviolet radiation from its sun, effects that may last long after the burst itself has subsided. This looming threat of gamma-ray bursts has become a focus of recent research, shedding new light on the potential hazards associated with stellar explosions that culminate in such dramatic and destructive events. When massive stars explode as supernovae, their brightness can surpass that of entire galaxies. This intensity raises an important question. What would happen if Alpha Orionis were to undergo a similar transformation? Should it explode as a supernova, it could become the second brightest object in the sky after the Sun in terms of visibility. Even at a considerable distance, the energy released in such an explosion might be so intense that it could be visible even during daylight hours. This blinding spectacle would cast shadows in the middle of the day, offering a striking yet unnerving experience for those witnessing it. While the visible light emitted by a supernova would undoubtedly be a breathtaking sight, the real danger lies elsewhere, in the high-energy radiation accompanying such an explosion. This radiation, typically in the form of X-rays and gamma rays, would have far-reaching consequences. One of the most pressing concerns is its potential to deplete Earth's protective ozone layer. Without the ozone layer, life on Earth would be subjected to dangerous levels of ultraviolet radiation, potentially leading to mass extinction events. The dangers posed by a supernova do not cease immediately after the explosion. The remnants from the explosion, such as shock waves traveling at nearly the speed of light, would continue to pose threats as they spread throughout the solar system. These shock waves could cause additional harm to the ozone layer, subjecting Earth to an even greater risk of harmful radiation, which would only heighten the dangers over time. Moreover, the long-term consequences of a supernova's energy release could linger for centuries, leaving lasting damage to the planet. Interestingly, some studies suggest that Earth may have already been affected by the aftermath of a supernova in the past. Elevated levels of iron-60, a radioactive isotope produced in supernova explosions, have been detected in deep-sea sediments and lunar soil, indicating that Earth has likely encountered the aftereffects of such an event within its geological history, possibly within the last few million years. At present, there are no known supernova candidates near Earth that pose an immediate threat. However, ongoing research is continuously uncovering new potential threats, particularly from supernovae capable of emitting long-range lethal radiation. These supernovae occur when a star nearing the end of its life is surrounded by a massive disk of material, and the shock waves from the explosion interact with this material, creating intense X-ray radiation that can travel vast distances through space. The concept of the habitable zone refers to the region of space where life-supporting conditions may exist. It appears that this zone might be more restricted than previously thought, with the outer regions of galaxies lacking sufficient star formation activity to support the development of rocky planets. On the other hand, the inner regions, where stars are born and die more rapidly, may pose risks due to the frequent occurrence of supernovae. As scientists continue to examine the remnants of supernovae, they are discovering that these cosmic remains can give rise to new stars, forming stellar nurseries from the expelled material. This process highlights the interconnected nature of the universe, where the death of one star often leads to the birth of another. In addition, supernovae have proven to be invaluable tools for measuring cosmic distances. Type Ia supernovae, in particular, are used as standard candles, allowing astronomers to gauge distances between galaxies with remarkable precision. This technique has refined our understanding of the vastness of the universe and provided crucial information regarding dark energy and the accelerating expansion of the cosmos. The remnants of supernovae, which consist of the material ejected during the explosion, play a crucial role in the formation of new stars. These remnants serve as stellar nurseries, where fresh stars are born from the gas and dust left behind. This cyclical process, where the death of a massive star leads to the creation of future generations of stars, drives the evolution of galaxies and contributes to the ever-changing structure of the universe. As astronomers continue to investigate supernova remnants, they are finding that new stars can emerge from the gas and dust in these regions even years after the initial explosion. Supernova remnants, with their complex compositions, are also one of the universe's primary sources of heavy elements. Elements like iron, gold, silver, and uranium are formed in the extreme conditions of a supernova explosion and are scattered into the interstellar medium, enriching the matter that will eventually form new stars, planets, and even life itself. Without these heavy elements, the solar system, and indeed our existence, would not be possible. Supernovae, therefore, are not merely destructive events. They also play a vital role in the creation of the very elements that make up the stars and planets we observe today. Furthermore, the study of supernovae has deepened our understanding of the universe's expansion. By observing the brightness of type Ia supernovae, caused by the explosion of a white dwarf in a binary system, astronomers can measure cosmic distances with extraordinary accuracy. These standard candles have revolutionized our ability to map the universe, providing crucial information about dark energy and the accelerating expansion of space. The precise ability to measure distances using supernovae has had ripple effects throughout astrophysics. By providing more in-depth and dependable methods for gauging distances across the universe, we have gained a deeper understanding of the rate at which the universe is expanding and how galaxies are evolving. The presence of dark energy, first inferred through observations of distant supernovae, has reshaped our understanding of the universe's future, suggesting that the cosmos is not only expanding but doing so at an accelerating rate. Yet, despite the incredible knowledge gained from these supernova studies, the potential risks from a nearby supernova explosion remain a fundamental concern. While such an event is unlikely to occur immediately, the future, albeit a remote possibility, demands our attention. The destructive effects that accompany supernovae, especially the shock and radiation waves they generate, can have significant impacts on nearby planets. If Earth were to fall within the range of such an event, the consequences would likely be catastrophic, from the destruction of the ozone layer to the disruption of the solar system's delicate balance. Understanding these risks forces scientists to think deeply about how life on Earth could be affected by such cosmic events. If the ozone layer were to be depleted by radiation from a supernova, Earth's atmosphere would no longer shield life from harmful solar radiation. The planet could be bombarded by lethal ultraviolet rays, leading to widespread environmental and biological damage. This presents an existential threat to life as we know it, making it essential for researchers to continue their studies into the effects of supernovae and other cosmic hazards. Interestingly, some scientists propose that early Earth may have experienced similar catastrophic events in the past. Evidence from isotopes found in ancient geological deposits suggests that Earth has encountered the remnants of past supernovae. This suggests that supernova explosions are not just theoretical risks but events that may have had a tangible impact on the history of our planet. Whether such past supernovae played a role in shaping life on Earth or caused mass extinctions is still a subject of debate. As research into supernovae and their aftermath continues to evolve, astronomers are also investigating the potential effects of gamma-ray bursts, GRBs. While rarer than supernovae, GRBs are even more powerful and destructive. These bursts can release an immense amount of energy in a fraction of a second, far surpassing the output of a typical supernova. They have the potential to sterilize planets by obliterating their atmospheres, including their ozone layers. This makes the study of gamma-ray bursts a significant focus of research, as their extreme nature presents a danger to planets situated within their path. The vast and mysterious universe continues to reveal wonders and dangers that challenge our understanding of space and time. As we study stars, their life cycles, and their explosive deaths, we gain insights into the forces that shape galaxies and the very fabric of the cosmos. One of the most intriguing fields of study is the death of massive stars, which can result in supernovae or even gamma-ray bursts, GRBs. These explosive events are far more than dramatic spectacles. They are fundamental processes that aid in the evolution of the universe. Supernovae, for example, serve as cosmic forges, producing heavy elements that enrich the interstellar medium. Elements such as gold, platinum, and uranium are synthesized during these violent stellar deaths, providing the building blocks for life, planets, and future stars. This process connects the death of one star to the birth of another, creating a cycle of creation and destruction that drives the dynamics of the universe. Gamma-ray bursts, however, present a much more immediate and catastrophic threat. These events release vast amounts of energy in a very short time, capable of sterilizing entire planets. The immense radiation from GRBs has the potential to strip away planetary atmospheres, including ozone layers, leaving the surface exposed to harmful cosmic radiation. The study of these phenomena is crucial, as even distant GRBs could have profound consequences for planetary systems situated within their range. As researchers continue to map the universe, they are uncovering the interconnectedness of all these events. The formation and destruction of stars are part of a larger cosmic dance that drives the evolution of galaxies. Understanding how stellar explosions influence the space around them provides valuable insight into the formation of new stars.